Hi and welcome to my next video. This is Manuel, Delta Lima 2 Mike Alpha November. Last time I showed you the QCX SSB modification, and I wanted to give you a brief update what has happened between the last video and now. Basically, QRP Labs in form of Hans Summers has made a decision that he will no longer continue the QCX revision 5 PCB. Instead of that, he went bigger. A little bit bigger. It's the same circuit, and we thought, should we continue modifying this or should we go a different way? And that is what we did. So this is the µSDX, one version of it at least. This is my interpretation of it. As you can see, it consists of 3 PCBs. Let's take it apart. This is the RF board. This is in this case I've made it for 70 meter band with low pass filter, choke coil or whatever you want to call it, shunt capacitor, and PA. In this case, we have now, this is the main PCB, first version of it, version 1.0. Atmega is now missing. And this was thought as some kind of breakout board. As you can see, I did a lot of experiments with it, because it was my first PCB actually that I ever designed in my life. So it contained a lot of mistakes, beginner mistakes, but it worked. So this was my IO PCB, and the reason I went further on that was because I've chosen the OLED as display. And it turned out that this thing is really noisy. As you can see, I had some layout issues here, and a lot of beginner mistakes. And this led directly to revision 2 of those PCBs. This is the main board again. I've redesigned everything, made the traces shorter, more wires, more ground, added some capacitors where needed. RF PCB didn't change much, but there was a mistake in it. And last but not least, I found an LCD that fits on there quite well, and with LCD I have no issues with noise. So let me show you how it looks like. Ta-da! This is the thing. Basically, the same concept as before, but this time with LCD. And I've taken out one of the 3.5mm jacks because anyway, microphone and key are sharing the same line, so I was out of space, and I thought I could just leave it out. Left, right, as usual, onboard microphone. This is push to talk and emergency key. It's not very comfortable to give CW. It works. It's just intended as emergency key. This whole setup has the size of a credit card, if you want to try to compare size. I have here a resistor for background LED of this LCD. One of the advantages of the green LEDs is that you do not need background illumination. It can be read without. So I went with that and saved another 10 milliamps in receive. Now I am at around about 50 milliamps of receive current. Yeah, the same class EPA, main board in between, rerouted everything. Yeah. Now let's go to the fun part. It works, as you can see. And now let's listen to some SSB.
Whiskey Tango Victor con over. QZ40 CQ exit 5WTV Zulu 5 Whiskey Tango Victoria calling 14 listening over.
Yeah, as you can see, pretty impressive for that small rig. Now, in the next step, I'm going to show you how I build it. So, because it's mostly surface-mounted technology, and yeah, it's not that hard. You can do it if you have the right tools, and it's actually pretty simple. This is how I do the main PCB. I ordered a stencil. I prepared it here. It's a piece of cardboard that has been cut out, and the stencil is just glued up. Just I look at it that it matches the footprints of the parts. Here I prepared my parts and my schematic and my bill of materials. Here's the solder paste and for placement. Now I'm going to put on the solder paste using the stencil on the PCB. Now I've put on the solder paste. And I'm trying to fit it in. Now I've kind of spread it everywhere where I needed it. I'm going to just flip that over and see the result. So now you can see every part that needs to be fit has now solder paste on it, and now I'm going to use this pair of, I guess it's called pliers in English, to place the components. I'm going to show you when I'm ready. Here you can see how I work. The 10 nanofarad capacitors are already placed. I cancel out every single one that I placed, and yeah, you can see here C1 and placed it on position of C1. And now I prepared the 100 nano farad capacitors. They are laying here, and I'm going to place them. And as you can see, I already placed the ICs, because especially the SI 5351 is very tricky. This one probably will make some trouble. We will see. So I'm ready with the component placement, and as you can see, I decided to place also the electrolytic capacitors. Yeah, no risk, no fun, right? Now put it carefully in the oven and see you afterwards. Now about 8 minutes later, this is the result. As you can see, looking really professional and good. That's the way I expected. And yeah, continue with the hand soldering of the ICs and diodes and jumpers and so on. I just wanted to add that I will put all of the layouts and data you need to build yourself one of those on a link I put in the description below, and if you can build one if you want to. It's absolutely open source, and yeah, you need to take care about your own PCB, but it's pretty easy these days. And just wanted to show you how changing band is done. I unscrew those four yeah, distances. I don't know how they are being called in English. You unplug it and you simply put in another one. This is a revision 1, but yeah, it works. Just stick it on and you're good to go for 20 meters. There are also disadvantages, of course, of this design, because you obviously need to order at least 3 PCBs, and if you want different bands right now, you need to order multiple band boards. You can swap them out right now, but as this is still very experimental and we do not know where the way is going, I thought I would go with some kind of breakout board, which is this one. And imagine the following: stacking up no human interface I/O board, for example. Just put on top of it like Raspberry Pi and do digimodes with it without the need for a computer. That would be possible with that design. And as you can see on this PCB, there's a lot of unused space. So this is just the first attempt. Experimentation goes on, and there will be multi-band PCB in the future. I don't know where the way is going. I'm experimenting still together with Guido, Papa Echo 1, November Zulu, the originator of the µSDX and the QCX SSB modification. We will continue experimentation, and yeah, we will come up with some solution. This is right now, this is yeah, the current state of the project. And just to mention it, there are a few other hams that did their own PCBs, single PCBs, really great designs. Actually, they're pretty much, and we were really overwhelmed by the interest that project was causing. I can at least, yeah, I think about 5 PCBs that several hams have done. Each have their advantages and disadvantages, and you might not be able to solder SMT like I showed you. So maybe your way to go is a single PCB like the old QCX was by Hans Summers, and want to solder that one. Yeah, there's many designs out there. Just check to groups.io for the uCX group or µSDX group and check them out.